All right, welcome to a brand new explainer. Today, we are looking at a complete end-to-end roadmap for training tomorrow's AI developers. If you've ever sat back and wondered, how a software engineer goes from writing basic, everyday code to architecting fully autonomous thinking AI, well, you're in the right place. We're going to decode the exact syllabus used to get them there.
So we're looking at a snapshot of a syllabus directly from the Agent Factory Paniversity. And okay, at first glance, it really just looks like a list of 9 web links, right? But we're going to decode this document line by line. Because let me tell you, this is definitely not your standard computer science 101. It is literally a blueprint for building the next generation of artificial intelligence.
We've taken all this information and structured it into 5 core themes. First, mapping the agent ecosystem. Second, the mechanics of agentic coding. Third, establishing trust and independence. Fourth, unleashing agents on the web. And finally, the final exam agent. Let's jump right in.
Phase 1. Mapping the agent ecosystem, setting the foundation for AI roles. Before writing a single line of code, this curriculum deliberately stops and grounds the student. The very first items outline the specific roles we are training for and the broader agent factory ecosystem. And why is that absolutely crucial for anyone entering tech today? Because, you just aren't building a standalone app anymore. You're building entities that have to constantly interact with other tools, other platforms, the whole shebang. This sets the stage so students know exactly what their ultimate job function is going to be before they even start building.
Moving on to Phase 2, the mechanics of agentic coding, getting into the trenches of AI engineering.
This is where the theory ends and the hard engineering really begins. We are introduced to local AI and agentic coding. So, with agentic coding, you aren't just writing scripts that blindly execute commands step by step anymore. You're building AI that has actual agency. It can make its own decisions, solve problems, act independently, and crucially, the syllabus has this starting locally, right on your own machine. It's a brilliant way to teach students how to run these incredibly powerful models securely and privately before, exposing them to the wider world.
Now this part is a real game changer. The syllabus mentions crash courses in loop engineering and harness engineering. These terms give us a peek into the deep, highly technical methods needed to control autonomous programs. Think of loop engineering as teaching the AI how to think in a continuous cycle. Evaluate, act, observe the result, and repeat. And the harness? Actually, scratch that. Think of it more like a safety harness. It's the technical constraints, the guardrails, you build to keep that powerful looping engine firmly on the track you designed, so it doesn't just spiral out of control.
Which leads us perfectly into Phase 3. Establishing trust and independence, validating AI behavior.
So, we've reached the pivotal middle of the journey here. Before unleashing those complex loops and harnesses out into the wild, we have to pause. We have to ask the single most critical question in AI development today. How do we actually know the AI is right? How do we prevent it from hallucinating or making some critical, catastrophic error?
And that brings us directly to a crash course titled Trusting the Checker. This is an entire module dedicated entirely to verifying the AI's logic and outputs before granting it true independence. In modern AI engineering, verification is just as important as generation. You literally have to build secondary systems, these checkers, that do nothing but audit the main AI's work. And then, as the title flat out says, you have to engineer ways to trust that checker. It's an absolutely fascinating layer of quality control.
All right, Phase 4. Unleashing agents on the web, taking the AI out of the sandbox.
Once that checker is validated and trusted, the creation finally steps out of the local environment. Think about how this evolution builds in 3 perfect steps. We started safe and contained with local AI. Then step 2, we graduate to a module literally called Leaving the Laptop, which tackles the immense complexity of dealing with external networks, latency, security, all of that. Finally, step 3, it arrives at the ultimate goal, building general agents on the web. This means the student is now successfully creating AI that can autonomously navigate the vast, wildly unpredictable internet to get things done.
And finally, Phase 5, the final exam agent, the culmination of the journey.
We've reached the end of the syllabus, and honestly, there's a fascinating twist on how these new engineering skills are going to be tested. The crucial point here is comparing the human student's ultimate goal, which is obviously passing this rigorous class, with the tool the university actually provides to help them do it. They give the students a final exam preparation agent specifically named the Zia Tutor.
This is where the whole curriculum becomes incredibly meta. There's a tiny note in parentheses that says, "will be available before start of classes."
Let that sink in for a second. They're using an autonomous AI agent to help human students prepare for exams that will test their ability to build autonomous AI agents. It is a complete closed loop of human and machine collaboration, baked right into the syllabus from day one.
So, as we wrap up this explainer, I want to leave you with one final thought to ponder. If this syllabus represents the new baseline, if AI agents are already seamlessly navigating the web and literally tutoring human engineers for their own exams today, what incredible, unseen frontiers will this next generation of engineers explore once they actually graduate? The foundation of the future is being laid right now. Thank you so much for joining me to decode this roadmap, and as always, keep questioning what's next.